In this video, we are going to look at something called intermolecular forces. Intermolecular forces are different than bonding in the sense that intermolecular forces happen between molecules, whereas bonding occurs between atoms. So intermolecular forces and bonding are still both dealing with the movement and locations of electrons, but bonding occurs between two atoms, whereas intermolecular forces exist between two or more molecules. So there are four major types of intermolecular forces that we're going to look at. The first one is called a London dispersion force, and these forces exist between all covalent molecules. So if a compound has covalent bonds in it, those molecules, once they're as a large group, are going to have London dispersion forces. You often see these, at least for this class, abbreviated as LDF. The next one are the ion dipoles. So these are going to exist between an ion, or a charged particle, and a dipole, which dipoles exist in polar molecules. So a dipole is caused by those differences in electronegativities that cause the atoms to pull on the electrons more one direction than another. So we've talked about that before, and that resulted in polar bonds, and it could result in polar molecules. So a polar molecule has what's called a dipole, and so an ion dipole interaction, or intermolecular force, is between an ion and a polar molecule. Our next one is called dipole dipole, and those are, so they're still the same dipoles from up here, so those are the interactions between two polar molecules. So if you have two different polar molecules, they don't have to be different, but two polar molecules could be the same or different. They're going to have what's called a dipole dipole interaction, or intermolecular force. And then our last one is hydrogen bonding, and this occurs in a specific set of situations. Hydrogen bonding occurs between a hydrogen and a molecule, and either oxygen, nitrogen, or fluorine. So if one molecule has a hydrogen and another molecule has an oxygen, a nitrogen, or a fluorine, it's going to cause what we call a hydrogen bond, which is really just a really strong intermolecular attraction between the hydrogen and the oxygen, the nitrogen, or the fluorine. For example, this occurs in water, since water is made up of hydrogen and oxygen, and this is one of the things that gives water such its unique properties, is the fact that it forms such strong hydrogen bonds. So this is the order that they go of in terms of strength of intermolecular forces, because not all intermolecular forces have the same strength. Our weakest intermolecular force are the London dispersion forces, and those exist in any covalent molecules. Or between any covalent molecules. Then we have the ion dipole. Then the dipole dipole is stronger than these first two. And then hydrogen bonding, even though it's not technically bonding, is our strongest intermolecular force. So let's look at how intermolecular forces affect our states of matter. So our three states of matter are solid, liquid, and gas. And so if we think of our solids, liquids, and gases in terms of intermolecular forces, our solids have our highest intermolecular forces, so these have the most, and our gases have the least intermolecular forces or attractions. So as we go from solid to liquid, we are going to break those attractions. And as we go from liquid to gas, we're going to break those attractions. So if we're going from something that has the most intermolecular forces to the least, we're going to break those attractions as we move through our states of matter. So going from a solid to a liquid is melting, going from a liquid to a gas is evaporating. Now the same thing happens when we go back the other direction. As we go from a gas down to a liquid, and then as we go from a liquid down to a solid, we're going to form those attractions. So gas down to a liquid would be condensation or condensing. Liquid to solid would be freezing. So in order to go from the least attractions to the most attractions, we need to form those intermolecular forces as we go through our states of matter. Now, before I talked about how the London dispersion forces were present in all covalent molecules, or between all covalent molecules, those forces are affected by the mass. So the more massive a particle or a molecule, the stronger the force. The less massive a particle, the weaker the London dispersion force. So that's another thing that factors into the strength of our different intermolecular forces. So in general, our intermolecular forces are what causes our molecules to stay together in their bulk, and it's what often causes our bulk properties that we see from our different substances.